Hello, welcome back for another chemistry lesson. Today we're going to talk about balancing chemical equations. In the caption of this video, I'm going to post a link so that you can access this document for a reference. And it's got, as you can see here, we're going to talk about steps and then we're going to work some examples. So the first thing you always want to do when you're balancing a chemical equation is to write the equation and all of the amounts that are given to you. And that just means however many are stated there when you're not considering coefficients, right? If we have a polyatomic ion and it's on both sides of the equation, so a sulfate on the left and a sulfate on the right, for example, then we can count sulfate as its own thing. And it makes counting a little bit easier. And then if we have water on one side of the equation and something with an OH on the other, then we can write water as HOH because that visually makes it easier for us to see that it's a hydrogen and an OH. And then this goes back to the point about polyatomic ions. So we can count them together. When you're balancing, you want to leave hydrogen and oxygen till near the end, just because sometimes they fix themselves when you're fixing other things. And then you definitely want to leave single elements until the very last. So if I have, for example, this first one we're going to work, iron, completely by itself, leave that till the end. It's the easiest thing to fix. If I need 7, I put a 7 in front. If I need 48, I put a 48 in front. I don't have to math for that piece. So we leave this guy until the very last. And then finally, if you have an odd number but you need even subscripts, we're going to use a fraction. I'm going to come back to this point whenever I get to an example of that because it doesn't make sense explaining it without an example. So let's get to our practice problems here. All right, the first step that I'm going to do is to write out all of my given amounts. So here's my equation. The things that I'm going to count are my irons, my hydrogens, and then you see here, SO4 is present on both sides of the equation. So I can count sulfate as a single entity instead of as sulfur and oxygen. So on the left-hand side of my equation, I have 1 iron, 2 hydrogens, and 1 sulfate group. On the right-hand side, I have 2 irons, 2 hydrogens, and 3 sulfate groups. Okay, so I've only got 2 things that I have to worry about balancing at the moment, my iron and my sulfate. We said before that if you have a single element, you want to leave it till the very last, so it's not going to be iron that we're fixing first. So the only thing I can change when balancing an equation is my coefficient out front, and we're going to multiply everything in that compound by whatever subscript we put out front. So in this case, I need 3 sulfates on the left, so I'm going to have to multiply that by 3. Now my sulfates are even. However, that also changes the number of hydrogens that I have on the left. So 3 times 2 gives me 6. So now I have to fix my hydrogens on the right-hand side. That's a pretty easy fix, because I could just put a 3 there, and that will give me 6. So now the only thing that I have left to fix is my iron. I need 2 of them, so I can put a 2 out front. You know you're finished when all of your pieces are equal on both sides of the arrow. Now you'll notice that I wrote this directly underneath the arrow. You don't have to do that, but I find it easier visually to see on the left side and the right side instead of trying to keep track of where the arrow is, because there's a whole bunch of horizontal lines in the plus signs, in the blanks. So I just find it visually easier to do it this way. You don't have to. That's my choice. So we're done with this one. All right, the next one, this is a combustion reaction. These tend to be the most complicated, just as a general rule. So first thing I'm going to do is write down what I am counting. There's no polyatomic ion. I have water on one side, but I don't have OHs on the other, so I don't need to change that. So I'm just counting C's and H's and O's. So I'm going to go ahead and count how many I have on each side. Okay, so remember I said to leave hydrogens and oxygens until later, so we'll fix the C first. I need 2 carbons on the right-hand side. In order to get that, I'm going to have to put a 2 here. But that also changes my oxygen. So now I have, and this is where it gets slightly more complicated. I have 4 oxygens here, plus the 1 oxygen in the water. This is a thing that is very easy to forget. So don't forget to pay attention if you have the same element in more than one compound. So I have 5 oxygens. Let me get rid of that. It's a little bit in our way there. All right, so now I can fix my hydrogens. Because the reason I'm choosing hydrogen and not oxygen is because right now I have an odd and an even number. I'm going to fix my hydrogen to see if that remedies that situation, because it's harder to deal with if I have an odd and an even number. Right, so I need 6 hydrogens on the right. I can multiply by 3, which will give me 6. But that 3 also affects my oxygen. So now, let's see. Now I have 3 oxygens here plus the 4 oxygens that were there. So my total is 7. All right, I have nothing else to fix, and I have an odd and an even number. So this is where that step I said I was going to come back to comes into play. If you need an odd number, but you only have even subscripts, so in this case, I need 7 oxygens, but I only have O2, I'm going to use a fraction where I have the number that I need over the number that I have. So in this situation, I need 7 oxygens. I only have 2. But rule of thumb, we do not ever have fractions as our coefficients. So the way that we deal with that is we multiply everything by whatever that bottom number was, in this case, 2. So this was on the left-hand side, the C2H6 was a 1. Now it's a 2. By multiplying the fraction by 2, it just eliminates this, and now it's a 7. This becomes 6. This becomes 4. So my new coefficients are 2, 7, 6, 4. Let's see what happens to our totals whenever I do that. I now have 4 carbons on the left and 4 carbons on the right. I now have 12 hydrogens on the left and 12 hydrogens on the right. And here's the kicker. This is the one that wasn't fixed. I now have 14 oxygens on the left. And then here I have 6 oxygens plus 4 times 2, 8. 6 plus 8 gives me 14 oxygens. So now, check, check, and check. Now we're finished. 2, 7, 6, 4. All right, now to the next one. Here, I have potassium hydroxide and phosphoric acid. I have quite a bit going on here, but I have some polyatomic ions that I can keep together. So I have PO4 there and PO4 there. So I'm going to count PO4s. I also have an OH on one side and a water on the other. So what I'm going to do is rewrite that as HOH. It's still H2O, but now I visually have an OH I visually have an OH, so that makes it easier to count. So I can keep that OH together, and my leftovers are a potassium and a hydrogen. So now I count. Potassium, hydroxide, hydrogen, phosphate, potassium, phosphate, hydroxide, and hydrogen. Okay. Let's fix one. Excuse me. Okay, so potassium, I need 3 on the left. I only have 1, so I'm going to multiply by 3. That also changes my OHs. So my OHs are now 3. All right, let's fix the OHs on the right-hand side. I need to multiply by 3. But that also changes my hydrogens, which is great because that's the other thing that I needed to fix anyways. So check, 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 and check. We are done. All right, I'm going to work 2 more problems with you. All right, this one, I don't have any polyatomic ions. I don't have an OH and a water, nothing like that. So I just count my elements. All right, so here, right now, the only thing that I need to fix is my oxygen. So I'm going to multiply that by 2 here. But that also changes my hydrogen. Gives me 4 of them. How do I fix that? I get 4 hydrogens on the other side. So that one was pretty easy to fix. All right, and last problem. Here, I don't have any polyatomic ions. I don't have any like OH and waters or anything like that. So we're just counting my elements. Okay, and right now, the only thing that I need, I swear that's my finger. Now the only thing I need to fix is my hydrogen. The other 2 are fixed already. Unfortunately, this is the situation where I have an odd number on one side and an even number on the other. So this is where we can use our fraction if we want to do that. The other thing we could do is flip-flop our subscripts. So that's the second piece. Let me scroll back here. If that doesn't work, write each subscript as the other's coefficient. Let's approach it that way and see what happens. Okay, so this 3 ends up here. This 2 ends up here. Now let's adjust our numbers based on that. Okay, here we are. So my hydrogens are fixed. It screwed up my oxygens and my nitrogens. So let's fix nitrogen first. I need 2 of those. But that also affects my oxygens. So now I have 2 oxygens here and my 3 oxygens there for a total of 5. Well, looks like I'm back in the same position again, having to use a fraction. So I need 5 oxygens here, but I have a subscript of 2. So remember, we use the number that we need over the number that we have. And then we have to multiply by that number that we have to get rid of that on the bottom of the fraction. So that eliminates this. This becomes a 4. This becomes a 4. And this becomes a 6. Now let's double check our numbers just to be sure. So I now have 4 nitrogens, 12 hydrogens, and 10 oxygens. 4 nitrogens, 12 hydrogens, and 4 plus 6 oxygens for a total of 10. So we are good. Okay, I hope that helped you figure out how to balance chemical equations. This is an incredibly important skill for basically all of chemistry if you choose to go beyond general chemistry. So this is something that you really need to get down. So I hope this helped. See you in the next video. Bye.